Hello and welcome to the demo of Epinio. My name is Andrew Gracie and I'm the Product Manager of Developer Experience here at SUSECON Rancher. In this demo, I'm going to be giving a quick introduction to Epinio and showing how it can be used to help developers create applications on Kubernetes. Epinio is a relatively new project being worked on by SUSECON Rancher engineers. It is 100% open source and built on top of several other off-the-shelf and commonly used open source projects. One of the core beliefs driving our development of this is that developers shouldn't need to learn all the ins and outs of Kubernetes just to develop for it. As you probably know, Kubernetes has a significant learning curve, and we don't believe that developers need to approach that learning curve. So let's go ahead and switch over to the demo. In this demo, I am running on just a single node K3s cluster on an Intel NUC that I bought a few years ago. Well, I have already installed Epinio on this and enabled the in-cluster services, which are provided by MiniBroker at the moment. As you can see on the right, we have a cert manager. I'm going to go top to bottom. We have a cert manager to give TLS out of the box. We have the Epinio API, which gives us a single point of access into our system. We have the Epinio registry, which allows us to pass container images between hosts for when you actually do run on a multi-node cluster. We have Gitsy, which we are using to store code while we're acting on it. We have obviously all the kubesystem stuff that comes from K3s, including Traefik already. However, if your Kubernetes instance doesn't come with an ingress controller, it will install one by default. We have MiniBroker to do service brokering. We have Quarks, which will allow us to do day two operations in an easier to control way. Service Catalog is a CNCF project that gives you an easy way to use service brokers and actually bubble that data into your application. Tecton is what we are using to actually do the pipeline running and to actually run the CI process that we have abstracted away, and more Tecton. So, just real fast to install the platform, it is simply Epinio install. It will actually pick up the IP address that it can use and will give you a default domain for that. It will deploy all the pieces that are needed, and then to install the in-cluster services, you can do Epinio enable services in cluster. And just to show it working, I'm just going to do a simple push of Dizzy Lizard. So this should go relatively quick. I just do a Epinio push Dizzy Lizard, and then because I want to see everything that's happening behind the scenes, I can say verbosity 1. What this does is this packages up all of your code into a tarball, pushes it up to the API. The API loads it into Git, which then triggers the Tecton pipeline that you can see running on this right piece. Each of these pipelines will run, and then it will actually run using build packs. So I'm going to stop the scroll real fast and scroll up and show that we are using Paketo build packs, which will automatically detect based on the code itself which build packs actually need to run in order to build the container image at the end. So I didn't have to tell it that this was a Node.js application, or that I actually instead wanted to run or I guess not a Node application, but a JavaScript application, and that I instead actually wanted to run Python with a simple HTTP server to host the JavaScript that gets produced. It just knew that. I didn't add anything to this. So I'm going to scroll back down. You can see then while I was explaining that, it completed. So I'm going to go ahead and open this up and switch my view. So you can see that the the URL that it gave me was indeed working. Um, you can see that it is using self-signed cert, and because I've run this demo recently, I'd already put that in my exceptions, and that Dizzy Lizard is working as expected. So I'm going to go back to the code, and how am I doing on time? I'm good on time. Okay, so I'm going to show how to actually use this when you have a service that you're binding to. So Epinio um, has a set of services commands, and I'm going to go ahead and start this creating and then explain what's happening. So it will actually, and we'll see it over here. Yeah, we can see that we have two Redis instances, a master and slave, that are being spun up because we asked for Redis to be created. This will go to the service catalog components and create the correct CRDs. And again, this is all behind the scenes, so the user doesn't have to know about this. But it will actually go and request the creation. Um, uh, the service broker will do the work to create that and then pass that back over in the form of a config map or a secret. I forget exactly which. Which then Epinio, when I ask for it to bind to the application, it will know how to do that, and it will put that in the right place. So let's go ahead and look at my index. And the important line to notice is that the URI, the string that gives the connection information to my Redis, is in a file that is mounted at /services/ in my case, my Redis, because that's what I call the services /URI. And I just need to read in that file, and then I can push it back as needed. So let's go ahead and push this application. Again, oh, I'm typing in the wrong window. So again, it's a Epinio push. Sample.js, and we can give it a verbosity again because we want to see what's actually happening. Now, this will fail. We know that up front because I didn't write my application to deal with the service not being there and not bound to it. Now, if I had not been lazy with my application, we could obviously have a fallback for that. So it's going to go ahead and build the application as needed, but it's going to be in crash loop back off at the end because it is looking for a file that doesn't exist for that services my Redis URI file. So while this is going on, it's going to happen. I'm going to, once it actually goes and starts and gets into a crash loop back off, as you can see, I'm going to scroll this over. We are in crash loop back off for our sample.js. Again, all of this is transparent to the developer, and probably by the time you're actually watching this recording, it will have fixed and made this a single step with a parameter to be able to bind in one single step. So I'm going to go ahead and all the work by Epinio has been done. So I'm going to go ahead and stop that um, and run Epinio services bind my Redis to the sample.js. And this will actually, you'll see this will terminate the old one and start the new one. And just for the sake of, um, I'm going to show that I've got these two apps running and sample.js is bound to my Redis. And I'm going to switch over um, to my application again, and we're going to approach it from a sample.js. I can refresh, and you can see that my emails are here. So I'm just gonna kind of type some stuff in, whatever. They're not emails, but who cares? And you can see that at least when I click refresh, there's some persistence. And just to prove it out, sorry. I'm going to go ahead and delete and force, just in case, delete this pod, and you can see real quickly it spun back up. And when I refresh, the data is still there. So just to prove out that we are indeed storing against a database. Um, and obviously any number of applications could be using the same database. And so thank you for attending this demo. I hope it was informative on where we believed the developer experience can go for Kubernetes, and that there is indeed a better way to do this. If you have any questions, feel free to contact me or any of the team on community.suse.com. Uh, Definitely feel free to try this out. You can find, and I should have put this on the slide, but you can find a link uh, at epinio.io. That's epinio.io. There we go, if I can spell correctly. And from there, you can find some documentation on how to get this installed. Again, the resources needed are very small and the installation is very quick. So I encourage you to try it out. Thank you. Have a nice day.